Well, hello my friends. It's been a while. I know, I'm sorry. Actually I've been going through a bunch over the last few years. As many of you've known, I've been gone for a long time, and probably most of you watching this would be like, who the hell is this guy? Well, 10 years ago I used to make videos, and this channel's chock full of videos, and I had a little bit of an experience where I changed my interests from model railroading to doing other things like making stuff. You know, everybody knows who's followed me for all these years knows I was a carpenter, and I got into laser cutting and using CNC routers and all that jazz. Well, that got me into Arduino boards and making products with other microcontrollers like the ESP32. I'm now getting into Raspberry Pi and stuff like that, and that got me to thinking, because these projects that I'm doing is, it's the best way to say it is I'm making a tricorder kind of thing, and it's got all these features that I started thinking to myself, well, that's something that could be used in a model railroad. And well, that's what this series is about. I'm taking these learnings that I'm doing with coding and electronics and microcontrollers and microprocessors, and using those lessons and taking them into the model railroading realm. And well, the way I learn things is I do very complicated things, and then go back and try to learn the fundamentals. I know everybody else, you go through school and you start at grade 1, you go up through that stuff. Well, that shit never worked for me, and I'm very passionate about the fact that, you know, there's very different ways that people can learn and people do learn. And you know, I know that I'm different than most, but if you were to explain my teaching process in a visual way, it would be taking the person to the finish line and pointing them back to the starting line and saying, that's where we start and this is where we're going. And well, we're gonna make a smart city, and we're gonna get there very quickly. In this series, if you follow along, you keep on coming back to the videos, you're gonna find out that we are going to be very quickly to a state where you never thought you could ever get to by your own fingers, because you are going to be coding everything, and you are going to be making everything that happens in this model railroad. You are going to take credit for every part of this. It's just like building a model. I can demonstrate building that model for you. I can paint it in front of you, and you can watch me do these things and learn, right? Maybe people didn't like me in the past because that's just the way I did things. Well, you know, I've found that with the new generation, they love that. And you know, I've been pulled out of model railroading because, you know, I really felt there was a little bit of you know, a little feeling about, they felt a little certain way about me. And well, that's changing. And you know, now that my teaching style has matured maybe, and I have matured, the way I teach has always been the same. I'm going to take you to the finish line, and we're going to go back to the starting line, and we're going to start learning the fundamentals from there. So I hope that you are interested in this series. I'm going to show a couple pieces of video with this little intro. However, we're going to do basically anything you want. You want to make a great big apartment building with TVs and lights that turn on and off at different times, and then maybe a photosensitive resistor that, you know, turns on the nighttime scene, you know, into all kinds of different things. Maybe you know, ultrasonic sensors that senses when a person is in front of the scene and starts the scene, or maybe a PIR sensor that, you know, will, you know, check out a number of different, kind of the same thing but different ways of doing it. And all in all, we're going to do some very complicated things. I'm going to make it understandable, and we're going to make everything step by step, and hope you can follow along. And if you're interested in getting the kit to have all the components you need for this course, give me an email or comment down below. Let's get in touch. Let's stay in touch. Let's keep this thing going. Okay? And if you're new to the channel, check out some of the old videos. Why don't you? They ain't so bad. Like, I've done things. Bro, sis, whoever you are, talk to you later. Today's video is going to be an intro to electronics for model railroaders. I have been learning electronics through other means, through robots, and see that? This has a turret that goes on the servo, and it turns and shoots darts. It's a really nice device. I guess I could put it on here too. And it uses an Arduino Uno as its control board, which is really fun. It got me into learning a lot of things like ultrasonic sensors and PIR sensors and servos, and just a number of different things. This is a very basic circuit, really, when it comes down to it. However, when it comes down to it, they're all basic circuits that we combine together to become a combined, complicated circuit. So we're going to start off very short here, very small here, and work with the fundamentals of what the components are. To follow this course, you can either contact me via email or on Facebook. My email is pare.ron@gmail.com, and I'm also available on Facebook, Ron Perry, P-A-R-E, and you can often find me administrating the Modelers Guild Facebook group with a few different guys. Modelers Guild Facebook group sadly lost our admin this past January. Bob Bujo was a very good friend, and I just would like to dedicate this series to him and another fella. Life came to a very big head for me when my family fell apart. I had Michael Paul Smith die, and about maybe 3 days later, my friend Todd Walton, who I made this kit for, I was in the process of making the video for his kit. You know, I felt it was a nice kit, and I hope he was proud of what he saw on his last few days while I was building it. I built it just for him, and when I contacted his wife about the model, she said just keep it and remember his name. So that's what we're doing. We're going to dedicate this video series to Michael Paul Smith. my friend, Todd Walden, my friend, and Bob Boudreaux, my friend. So what's the hardest part of this hobby? Anyways, let's get back to it, shall we? So, I'm autistic. I didn't know this my whole life. I didn't really start to realize this until I became a father to my son, who is definitely autistic. Shows all the signs of stimming and doing various things that autistic people do. However, I don't do that. So I lived my whole life thinking that I was had attention deficit disorder, when instead I had attention you can't get my attention by hitting me with a bat disorder. And throughout school, I was lost. I was completely lost. They put me in a fucking supply closet, and I learned most of my classes from there. It's really changed my life. And if you're a teacher out there and you're doing this to some kid, I want you to think about what you're doing. I really want you to think about it. Because if that kid grows up to be me, I want you to be embarrassed. I want you to retire, or I want you to quit. Because if it was up to me, you'd be fired. Not because of the classes you taught, but because when you were taught to teach the way you were, you never challenged the system when you thought that maybe there was something wrong going on. Because I should have never been in that class with Down syndrome kids. Should have never been there. Anyways, let's get to this, because I'm getting depressed. So, my point in saying to me I'm autistic is that, I get bored very easily. And if you start with mathematics and reasonings and naming conventions and all this jazz, you're gonna lose me. Because I don't give a rat's ass about the small details. Why? Because when I go to learn, I go after the small details on my own time. It's my job to take care of those details. And in this course, it'll be your choice to take care of those details if you don't. If you want to. In this course, we're going to be sharing some general values that work in our voltage range. In our purpose model railroading, it has been pretty much set in stone for about 100 years now. So, if they got it wrong, it's been wrong for 100 years, and I ain't gonna change that shit, and I don't think you are either. So, we're gonna avoid pulling out the calculator, and we're gonna avoid the multimeter for the most part. Got one right here just for posterity, I guess. However, I want you to note, if you don't have any of these components, our breadboard here, our little devices, you don't get a starter pack. If you don't have that, you can contact me to get a starter pack at a reduced rate. In Canada, it's $90 to get the starter pack for the Arduino kit. And I have been able to purchase basically the same kit for probably about $30–40, right? And that's Canadian. So you know, you convert that to American, it's probably about $10 or $20 cheaper, or 10 or $5 to $10 cheaper on the low end. So what are we going to do? Today we're going to start off with the LED. We got this LED here. And there's a couple of things about an LED that you should know. Its LED stands for light emitting diode. You know what a light is. You know what emitting is. The cartoon lines of and the diode is actually a gate that is powered by a low-powered lock that allows electricity to flow from one direction to the other direction. But it doesn't allow it to reverse that direction, which is pretty good for many different cases in terms of circuitry. However, we're going to start off like I always start off. We're going to start off by doing what you're not supposed to do. I often like to find out what happens when you do what they say not to do. And, well, we're going to do that today. So, an LED has some features. So, if you... There it is. Okay, so if you feel around the edge, you got the top and you got this little ledge of plastic here. On that ledge of plastic, there's a flat part. And I'm never going to be able to show you that flat part. Maybe you can see it there. If I go like this. Focus in. You're going to find out that on this there's a short leg and a long leg. And on the short leg, there's a flat spot on this collar here on the plastic. And that denotes the negative cathode of our diode. This is the exit of our power. I like to say that the long leg, you put your best foot forward. You know, we always want to be a positive type of person. And keep on putting that out of the screen. I'm going to move that thing right soon. Anyways, we got a long leg and a short leg, and then put your positive foot forward, and that's how things are going to go. So we've got a breadboard here that I took apart to make into a great big breadboard. If you notice, breadboards will pull apart. These power strips will come off, and the internal parts kind of look like this. You know, just the small joiner rails that are in there. And this is a good demonstration of what they are. They kind of join all the wires that go into the holes only in that one line, as you can see here. You know, so all the ones on this side are joined together, and on this side they're joined together on their own route because there's a break in the middle, as you can see. And these aren't connected together in each side, so each of these lines are separate rails, making it very easy for you to connect your different components to a project and, you know, not get lost or, you know, have it get so confusing. And because things get really confusing, I have expanded my board all the way out to be able to show you the best possible way to get this project going in a way that you can understand. So we've got our, I'm going to put a black wire in over here. There's a few away from the red one. Put the red one in there. So that means that our blue line all the way across here is powered. And our red line, well, when I hook it up to the battery, it'll be powered. When the red line is positive, all the way along here will be powered. And when I jumper across from the red to the red here, it'll power this strip on the red line as powered, and on this strip I powered the negative so that it will go all the way across powered. So now if I take my LED and I put it in straight across the bridge in the middle, and then I take a little jumper here, jump it into a black line there, and then make sure I'm in the same row as my LED. Flat back there. I use the red wire. We'll go into the same row, and then we'll go into our positive power jumper. Do a little twist on that, get it out of the way. And we'll get our battery and we'll put it on the right side. And as you can see, we got a light. Now, this isn't ideal. Why? Because our LED isn't really set up to take all the current that this LED or this battery can push. And if we have a smaller LED, it would clearly burn out as quick as we could get it to. So just to demonstrate, if you turn this battery around to demonstrate the leads being backwards, you can see that it doesn't work. Okay, so I just want to do it one more time to maybe show you that when we plug it in, there will be an effect. What happens is the LED will come up to full brightness, and then it'll start heating up, which will add resistance to the diode, which will lower the voltage being put through it, and it kind of dims out a little bit. Okay, so it did it. I don't think you were able to see it, but that's the way it works. Anyways, so let's move on. Pull this wire out here, and we'll come over to one of our standard LEDs that we're going to be using for LEDs. Our standard resistors. The resistor we use predominantly in model railroading is the 200 or the 220 ohm resistor. Now, let's pull up the screen here real quick. So if I go like that, image, let's retry. So if I bring up this image here, you can see that to find out the value of a resistor is kind of very easy. We can see on our resistor here, if I bring it up to the camera, that what we have is a red, black, brown. Okay, so that's a 220 ohm resistor with a plus or minus of 5% accuracy. We're going to put this on the positive line. However, it won't hurt you if you put it on the negative line, because what we're doing is we're impeding the current across our LED to be able to run it without burning it out. We're going to control the current through it. And this is a point where, other videos would pull out their ammeter or ohm meter and show you the differences in ohms. And I'm just going to tell you that, we just don't want all the current to go through this thing, because we want to have a fast video that gets to the meat and potatoes really quick. And this video has already started to get long enough for my tastes. So now we've got a light that turns on, and we can leave it on. We don't have to worry about it ever turning off. If we wanted to change the value of our resistor, we could. We could put a bigger resistor on. Okay, so I'm going to quickly go through this project so that we know what is going on. Just gotta make sure all these things are hooked up here so that they're going to work. Oh, we got a problem here. I tried to use a couple of broken LEDs. Once again, you can tell that like I got the legs cut off here. However, well, that's where they're touching right there. As you push them into breadboards, they kind of fold up on each other, and like this one's ruined. I just pulled the leg off of the cathode side. I can see the cathode side very easily now. Hope you can see it. On the very top here is a flat mark, and that will show the backside, or the short leg, the cathode. The front side is the anode, our best foot forward, the long foot. And this is now a ruined LED. Big deal. We got thousands. What we've got here is a circuit that would have been completed if I would have left that LED alone. Dang it. Okay, so I'm going to put the anode and cathode in the right spots, and I'm going to put this negative terminal in the cathode side of the red LED. The first goes through the... So what we got is our positive line that goes on to from this bar to this bar, and then it goes over to this bar. Then we take our resistors and we put them over into this line, which goes into the blue LED, then the red LED. If I take my negative wire and put it on the other side, you can see they both light. Now that's fun. We've got another demonstration to quickly go through to show you. We first demonstrated that an LED will work if it has the proper direction without a resistor. However, it puts too much current through the system, making it so that the LED will burn out in most cases. And this happens because a diode does not limit current. It lets it pass straight through it. And that's a convenience and an inconvenience in many ways. So if I take my negative here and I put it on the backside of the second red LED, we turn on 3. I put it in the backside of this yellow LED, we turn on the yellow LED, but you can see that the LEDs have reduced in brightness. And you see that's nice and bright. And now you can see particularly on the yellow LED, and I put the green one last because this makes it very obvious to see which one, how it's all reducing
you see how all the lights all the way along this are very dim, but our green is just blaring away. So this shows that even though we've got current going through these things like wildfire, they do have a resistance value that steps down the electricity and is handled by the different colors of the LEDs differently because of their wavelengths. They will obviously have a different ohmic resistance. So how do we fix this? What do we do to make it so that we can light up an apartment building? So what I'm going to do here is I'm going to take a LED and I'm going to make a new line. I'm going to put, we see that probably, like if I take one more LED and I put it in this line, I think it might break it. If it doesn't break it, it'll be the next one that breaks it. Yeah, see, it's pretty much broken. I put my hand over the light. You can see that no LEDs are lit except for the green one. And the green one obviously doesn't need a lot of power to go through it to light it up. All the rest of the voltage is being sucked up through these LEDs over here. So, we want to make an apartment building for our models. And we want to have lots of lights go through it. And not only that, but we want to have our lights come on and off in a way that mimics human behavior. So let's quickly put our LEDs in here. We're going to put 4 in each line. We're going to start this one with this LED. Each of these LEDs are the 220 ohm resistors. Oh, each of the resistors are 220 ohm resistors. Running out of white one's big deal. And we'll do this last line over here, best foot forward. And just keep the lines going. Now, what's happening is the long leg is going into the short leg's hole of the LED before it. So it's kind of like a series circuit. The circuit goes through here on series. However, what we're going to do right now is use a different kind of circuit called the parallel circuit. And what the parallel circuit does is it will send the equal 9 volts of electricity through our bar, through each of our circuits here, and each will get 9 volts instead of being chopped down from 9 to 8 to 6 to 5 to 3 or something. You know, it's or your amps or wattage. You know, however you explain it, it doesn't make much of a difference. So, because each one ties to another one in a very integrated way. So we turn on our first set of LEDs there. They're pretty bright. We're going to stick in our second ground. We're going to put on those LEDs. And as you can see right away, our LEDs are bright AF. I don't know if you know what AF means, but it's for fun. We got mistake here. Maybe 3's our limit. But as you can see, we've already have 9 LEDs, whereas before we had 1, 2, 3, 4, 5 LEDs, and they were pooched out before we got to the whole thing, and we haven't changed anything. We're still on a 9-volt battery here. And I'm even going to take this last one, put it in our green route, and I can't see the blue, I can see the red, the yellow is just slightly on, and the green is on. If I take out this green and move this ground over to the yellow, we can see that those lights turn on nicely. And if I had another resistor, I do have another resistor handy. We might as well just do it instead of people thinking that you don't know what you're talking about. So the mathematical reference we're talking about here is V equals I times R. And that means voltage equals current times resistance. And this voltage equation is really the fundamental equation of electronics. Gives us the ability to mathematically know what is our limit. And our limit was basically under 9 volts, 4 of these LEDs will work. But changing the circuit from a series to a parallel circuit doesn't change the amount of lights that can turn on in a certain line. So we went from this LED, this 9-volt battery, hardly pushing 5 and 6 LEDs in a series circuit, and then turned it into a parallel circuit and turned on 3, 6, 9, 12, 16. So we've got 16 LEDs here, all working, all potentially on their own on-off switch, because each of these black lines right here could be a switch that turns on and off our LEDs. So this is an entire apartment building. And quickly, very quickly, within the first few minutes of our video, we have figured out a circuit that can totally light up an entire apartment building. Our next video, we're going to go into timing, aka capacitors. Okay, so once again, we are not going to school here. I'm not going to go through each and every bit of information because we're just going to hook up the carburetor and make it work. You know, when somebody tells you how to fix a carburetor or get your gas running lean or whatever, you know, get the mixture run right, you know, some people will sit there at the blackboard and tell you every single detail. And, you know, after you get up from your nap, you get to the car, you don't know nothing. Okay? And other people will give you the screwdriver and say, well, there's the screws. This one does this one does that. Let's listen to the engine while we'll turn it. And that's all the information you get. And that's all the information you're going to get today, because that's all you need. And that's all I ever needed. And I'm somebody who, you know, like I said, spent time in the closet, you know, with the hard R's. So I don't mind. What we've got here is it's a push button. It's a switch. The significance of this switch is it's got 4 terminals. And what that means is, if you look at the top of the switch, there is 4 dots. And those 4 dots are basically an X. So if I have a wire that comes from negative and goes into this side, and I press the button, this side right here is not going to show nothing. Okay? That side right there ain't going to show nothing. Okay? And I guess we'll just have to demonstrate it. No, forget it. I'm not doing that. Forget it. We're keeping this video quick. Okay, so to make this switch work, you have to do on the X pattern. You know, so it goes through the switch. It does a 45-degree angle to the other pole coming out, and you go to your positive. So that's a complete circuit. I don't have it plugged in here, so don't worry about short circuiting or anything like that. So that's these switches. That's how they work. They're like an X. And when you put the wires in on one side, you got to put the wires in on the other side of the switch on a 45. Okay? Simple. Done. Okay, so what we're going to do here is we're working with another component that has a directional flow. Okay? Just like the LED, we put our best foot forward. But the great thing about a capacitor is it's got the line on the back that shows that it's the negative. Okay? So to make this, we got our best foot forward. And to make our circuit here, our timing circuit, what the heck does this guy mean about timing? Well, if you add a capacitor is much like a battery. However, a battery has a chemical component in there to slowly release the potential difference of the battery or the voltage. Okay? That's what its purpose is. It's charged up and it slowly releases its charge until it's done. Okay? A capacitor is just 2 plates beside each other, basically, and they charge up in the same way as a battery. However, when they get to their prescribed release point, they discharge very quickly. And they measure that in a half a second. And that half a second is 5 equal cycles. So a second would be pretty much 10 cycles, right? So in this, the first cycle will do what is it? 37% of the charge, and then it'll when you're charging up, it'll do 67% of the charge in the first step of the 5-step process in the half second, right? So in the first 0.1 of a second, it'll go 67% charged. And then the rest of the 4 points are, the evening out of the line. You got those lines never go 45 on a graph. They go up and then start going over till they get to 100%. And then the same on the discharge. It will discharge 67% down to 33% in that first 0.1 of a second, right? I'm saying 0.1, but it's actually like 1/5. But it's whatever, I already said it. Doesn't matter. Okay, so this is a timing circuit. Why? Because we're building up the charge, and, well, just let me show you what happens. So what we've got here is a 470 microfarad capacitor. On this circuit here, we've got a 220 microfarad with a 100 microfarad. The next one, we have a LED. We got 47 microfarads and 100 microfarad. And over here, we just have a simple little 47 microfarad. So, to make our circuit, I'm going to start by putting my negative in my negative side. I'm going to take a 1000 ohm resistor. I'm going to jump it over. Let's just do it. We're going to put it in the same line going into the switch as the capacitor. So this is all going into this side right here. I'm going to come out on this side. We're going to put our LED in line, and it's going to be on the other side of our resistor. Actually, just because this fits better this way, I'm going to put my best foot forward towards the switch because we're on the negative side this time. And I'm going to make sure we're... God, this is the worst. I had it all set up, but then I thought, it'll get through to you a lot easier if you just watch me do it. Okay? So, I've got another one right here. I know that this is my negative side. I've already got the poles cut off because I already used it in a project. Or actually, maybe I pulled it out of a project. When I first started and I didn't have any money, I brought home a couple of pieces of electronics and stole the components off them so I could do this. However, we're going to show you in a second that you don't need these components to be able to do this circuit. Even though it doesn't really work all the best for me right now. Okay, so I'm going to spread that out like this. Okay, so we're going to go on this side of our switch. I'm going to put this closer to the switch because I want to get this in series so that we can add these capacitors up for our LED. Okay, so it goes from minus to the plus side of the capacitor. And then on this side, I've got my line on this side, and then the positive side's going into the switch. And then I'm going to take my resistor, and I'm going to put it in line with my capacitors. I can put it in anywhere. And then I'm going to take my short end, put it in the negative, and put it on the other side of that resistor there. We're quickly going to move on to the next switch where we've got a 220 and a 100 microfarad. Okay, so these ones have full legs, so I'm just going to put those both down. This one with the leg in the spot for the switch. We're going to connect these two lines for our capacitors. Let's pull this back here behind there. And then we are going to put our LED in right there. And we're going to put our 1000 ohm resistor in between the resistor and our series capacitors. So we got, sorry for my head. And then we'll put this side over connecting to this LED. So that's a jumper that gets across. This is the jumper that connects these two in series, or parallel, I mean. Actually, I got this one wrong then. Okay. So that I want to have Okay, I'm gonna have my legs coming out straight. I had this in series, not parallel, and I just noticed that. And I don't like to make mistakes. So we're gonna put this in the one side of the switch, and I'm gonna use my next line, and instead of being on the same, uh, okay, and then we're going to connect these two lines that are right beside each other. I could use a little wire, but it would be not as fast as doing it this way. Okay, so yeah, I should have just grabbed a good capacitor there. But forget about this one. This one is just because it's the short and curlies involved. But this is the way it's done. You go from your negative to a line of its own. You jump her across to the point that's all going into the switch. Our LEDs going into the switch, all in the same terminal there. And then we'll do the same thing over here, going into the switch at the same point. I'm going to grab my resistor here. I'm going to put this in line there and make sure it's in. And where's my last LED? I wanted to use oh, there it is. Red one right there. Okay. We got it. Okay, so the negative goes into the negative, and positive goes into where the resistor is. Again, sorry for my bald head in the way. Okay, so our circuit is almost done. Okay, so we've got this all hooked up over here to be the capacitors hooked up to the LED. The capacitors hooked up to the LED and then the LED is being protected with the resistor. Everything's all right. And then we're going to go, it's going in on this side. So I'm going to come out on this row right here and go like this and bring this into my positive. Do I've got more red wires? I like to use the right wires so that we can visualize this properly. I like to put a twist on them too. I don't want to wreck that project. We're going to use orange wires. Almost. There's a red one. Probably as long as I'll get out. Okay. Yeah, the one's kind of long. Who cares? So, once again, we put it in this side, the opposite side. There. And then we'll just take this over here. Put a little twist on that, get it out of the way. And then this one, once again, we're going in on this side. So we're going to come out on the opposite end on a 45-degree angle. And just plug in our wire there. So now we've got our wires. Got that on. Whatever. And we're going to plug in our battery. And I found out that I looked at my video and everything was all shitty last time. So what we're going to do is we're going to turn down the lights. Maybe even turn them off. Okay, so now when I press this switch, you can see. What am I doing wrong? It's not plugged in. Okay. So you see how the light comes on right away, but will fade on the way out. You see that's a slow, a little, like, instead of an immediate. See, if I pulled out this resistor, you could see there is no It just goes on and off, on and off, on and off. But if I add this resistor or this capacitor in parallel with our light, you can see that when I let go, our capacitor uses its power to let go with a little bit of a delay. Cat, you're enough. Hey, so go to the next one. What happens here? Nothing. I gotta get a better resistor for this. This is garbage. Okay, forget about this one. Shut up, cat. Okay, so forget about this one. I screwed up with the resistor or the capacitor. Actually, everything's all kind of screwed up there. Probably would have worked. Okay, so now it would have been a lot slower if I had my second capacitor in there, but you can see as well, it comes on right away, slow burn off. Comes on, slow burn off. It'd be a lot slower if we added our other capacitor, but who cares? We got this one to show us the way. So once again, it goes on right away. And when I let go, it takes much longer to turn off. The half a second is really there. Actually, I think that's 5 seconds. If I look at the math, it's still on a little bit. It's actually still on. Oh, wow. It's just turning off right now. I'll do that one more time. Boom. So as you can see, when you add these capacitors up to our circuits, we can do some major things. This has a 470 microfarad capacitor, and you can see it takes a lot longer for that one to go out too. You know, so boom, boom, boom. I think that if I put my blue over on this one over here, change this red one out, it would probably be a lot longer because, like we said before, some LEDs take different power ratings, and we'll have different activities. So we'll go like this. Let's do them both at the same time. So, well, this one wins. Okay, so as you can see, though, this is a timing circuit. Okay, so this one has, we'll let go of the switch and I'll start counting. 1. So 1 sec, not even 1 second. This one over here, we go 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10 Mississippi. It's still on, but you know what I mean. Okay? So, once again, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 4 seconds basically on that one. So as you can see, capacitors are like batteries, but for the most part in electronics, they're timing circuits. They're timers. Okay? So these will add life to our circuits. And the thing is I want you to note that we haven't even touched Arduino yet. Okay, so a lot of the control in our layouts throughout the last 100 years have been controlled only this way. You know, it's a little bit of a mess. It takes a little bit of a a little bit of thought and stuff like that. However, if we connected our LEDs to wires and put them up in the building with all the electronics below, it'll still do the same thing, which is remarkable, right? So hope you're seeing what I'm seeing, because when I was doing my other project over here, you know, I'm doing a ultrasonic sensors. I got a potentiometer. I got a switch over here. I got my LEDs doing I made it into a intersection light, a light for traffic light. And then we have over here data that comes from the ultrasonic sensor. And then we've got an IR sensor here for remote controls. You got to be able to read your remote controls, and I had the hexa control. Well, actually, it's the new version. Like, I had the number come out in here, so each button has a different number, and it's read through this, and then you can put it through your programming. Blah blah blah. You'll find out about this later, because we can do a lot with our layouts with one of these. And you're going to find out how to control these things through this course. Well, if it gets a response. My videos lately have been only getting like 50 views and stuff like that. And I'm not going to invest $500 getting kits when there's no interest. So if there's interest, please place your questions below. If you've got any questions, there are no stupid questions. You'll find out that I won't be ignorant. I'll be giving you all the time in the world and all the patience in the world. And maybe we'll have a Q&A video after that. I answer questions in the comments. Okay, so let's move on to our next project. I forget what it is really. I think it might be something. Thanks for watching this lesson. Okay. Try this again. I think my transistors are broken, or I got the wrong ones. They might be PNP instead of NPNs. However, I've got the same circuit here, all dialed in, and it's the exact same as what it should be on the board, and I think it is, but we're just gonna have to figure that out later. I don't know. I've had transistor problems and had to come over to TinkerCad every time I do this demonstration to be able to get it to complete, which is pretty sad. Okay, so how does this work? We've got our positive coming through here. We've got our resistor, our 200 ohm resistor, 220 ohm resistor. This is a 200 ohm. That's going into our LED anode. Coming out from the cathode, we go over to the collector of the transistor. Over on the is that wrong? Okay. Let's see if this makes a difference. Oh, it does! Oh! Okay, so we still have a problem with our transistor on our board. It's just the orientation of the transistor on our breadboard here in TinkerCad was backwards. So we've got a jumper coming from our cathode all the way over to our collector, which is our positive, what I was talking about, positive, and it's going through to the emitter, which is coming over here to get jumpered across all the way to ground. Our base, or I call the gate, it has a 10,000 or a 1,000 ohm resistor, and it is coming across here to give a parallel circuit to our transistors. As you can see, they're both connected to ground, and they're both going up into lines that are connected to this, so that they both get their 9 volts, and our resistor comes across, and it goes into our switch over on this side. This side is the way these switches work. As I said, 45, 45, and it's going to positive. And as you can see, our light looks like it's still on. You press that, let go, and it takes a while to turn off. You can see it's still going. It'll be, and this is what's known as a 75-second circuit. So, I got to figure out what's going on with my transistors. I believe that's what my issue is. However, this is how the circuit goes, and use TinkerCad. It's a great simulation device. So there you go. Let's move on to the next one, because this one was embarrassing. I think the next one's going to be a problem. We're going to have to use TinkerCad. Okay, so in this lesson, we're going to do something different. Like I said, when I started, I was recycling parts off of old pieces of electronics that I found in the garbage, e-waste garbage. I'm not going into the garbage. I have a friend downtown who runs an automations company and gives me access to his e-waste garbage. I have a key so that I can get in and get what I want and bring home what I want, and then bring back what I don't need, just to make sure that everything that he throws out is actually garbage. Which is a great deal. He's a great guy. Thank you, Brent. However, if you don't have access to a friend like that, if you are the type of person on disability, too much time on your hands, and still want to learn, still want to be an active, productive person in society, all kinds of different reasons. If you're work in a factory and you want to upgrade your job to maintenance or robotics, learning this stuff is the first step of wrapping your head around the thing that is engineering, electrical engineering, programming, microcontrollers, and microprocessors. The good thing about TinkerCad, what you're looking at now, is it's free, number one. Number two, it has all the basic components you're going to find and need in learning these projects and in experimenting. When I say experimenting, the potato battery really comes into play. Or the lemon library, or the battery. I don't know. You do you. So today we've done a number of circuits: the series circuit, the parallel circuit, the timing circuit. Well, this is another circuit that a city will use every single day. Day. Yeah. To save electricity. You're going to have to accept the cat. It's a rescue. I never went out and said, "Oh, I love you, Duster. I want to have you in my house for the rest of your life." He pisses on my clothes, and I hate his guts.
but I allow him to do whatever he wants. How are you gonna teach a cat? The litter's clean. I don't know what the fuck. I don't know. I'm his master. It's just the way things work. Okay. So let's change this to basic components. So that we're in the electronics cycle. What we're going to do today is make a street light Dusk-till-Dawn switch. So this project is something you see in every city. It consists of a light emitting diode that is or light emitting resistor. What is this thing called? Photoresistor. It's a photoresistor. So I've got a photoresistor here, and what a photoresistor does is during the daytime when the light is at its brightest, it adds impedance to the circuit to basically shut off the lights. It's not a centrally controlled system like sometimes today. Back in the 80s, back in the 90s, this was the thing that was used to control our streetlights everywhere. Okay? So let's recreate this, because obviously if you're going to have a model railroad, you're going to want to mimic the smart design of a city. Okay, so we'll put a photoresistor in there, and we'll put a black line onto this, and we'll take this. This is doesn't have a direction to it, so we're gonna go from that's the one thing I don't like about this board, is that it does have, like, it hides things on you. That's a shame. Okay, so we're gonna put this line here, we're gonna put this line here. Okay. Let me look back at my cheat sheet. Okay. So what we need to do is we have to get a what's called an NPN 2222 transistor. And this transistor is going to be placed on my board here differently than how I have it placed on my breadboard in real life. We're going to demonstrate this in IRL just after we do this. But first we have a few things that we need to do. So our photoresistor is going to control the gate. Now this transistor is has a gate, and it's got a positive and it's got a negative. Okay, so on our negative side, we're going to take this, put this over here, and then finish the circuit over here. Boom. Okay, so now we want to grab something over here and something over here, finish off our circuit. So we've got a red LED. I don't like see it. It's backwards again, and I should probably just start putting them on this side. Whatever. Okay, so we've got our LED. I'm going to take a red line here. I'm going to put a jumper to our positive. Then we're going to move our LED over here. And we're going to take our, I think it is a 1000 ohm resistor. you know, 1K ohm is the same as 1000 ohm. So we'll take that. We're going to press R to rotate it. I'm going to take this from the negative. We'll put that into the transistor where it needs to go. We'll move this over, and we're going to move this over. Okay. So that's basically our circuit. When you want to run your circuit, you press start simulation, and you press our light. Sometimes it just don't work for me. Okay, let's just get over the breadboard. That's just demonstrating some horse crap, over here. So let's get over to our board. So for our project here, I hope the lights aren't on too high. I'm gonna turn them down a little bit. Okay, so that you can see. So now we've got our transistor here. It's got 3 legs, just as you've seen before. I like to take the flat end and always put it to the right side, so I know that my transistors sitting the same way all the time, and that way I know which poles are which. So now I go and put that in there. I'm gonna take my jumper here. We're gonna put this into our switch, which is the middle terminal. You remember that the middle terminal was connected by the photoresistor. We're going to take our 1000 ohm resistor over here, and we're going to take our LED over here. Our LED is going to go into the positive side of the transistor, and our resistor, it's a transistor, and our resistor itself, sorry for my head, is going to go and give us some, you know what, I'm going to change this just because through all my drawings, I have it the other way around. And I think I spun this board around when I put it on here because it's got a flat edge this side, flat edge this side. And just the way it's sitting right now is just not working for me. And we're changing it. Okay, so we're going to take this one off. Put that over there. We're going to put this negative one on. Twist the wires. I usually tin the wires so it's easier to put into the breadboard. These have been tinned. However, I've been using them for the last 2 months like a madman learning this stuff. And, excuse me. And you know how things go. So there we go. We've got our positive and negative, our LED and our transistor ready. We're going to take our negative side of our transistor, which is this wire right here. Right there. It's connected. Okay, so as the power comes in, change this over to the positive one. Make sure they're in the same lineup. They are. Positive. Best foot forward. The flat side of the thing. The short leg goes into the positive side of the transistor.
The yellow line comes out the negative line. The orange line goes into the low-powered switch that activates our switch. And transistors are basically a switch that is controlled by a low-powered connecting point. Kind of like your finger. Just think of that as a little baby's finger. As opposed to your finger, which is probably, twice as big as mine and whatever. So what do we do now? What do we do now? Okay, so we're gonna take our second resistor, because like I said, it was a low powered, so it's a 1000 ohm resistor, and this is going to cut down our power for our transistor. And as you can see, because we don't have the photo emitting diode, it just turns on, right? Because it's got power going into the transistor, opening the gate, going through, and it works. I'll turn off the light real quick just to demonstrate it one more time for you. Because there's no resistance in there, the street lights come on when the lights go out, okay? So now we've got our light emitting diode and our photoresistor, and that is going to go in one side of our switch, and it is going to go all the way to the negative terminal. I could have jumpered it, but I'm not. Okay. So, everything looks good here. And now we'll turn on our battery. Is my transistor broken? Maybe I've fried it. So what we're looking for is an NPN2222 transistor. I don't know if I got that one wrong or not. Okay,
I wanted to finish this video with a crossbuck, flashing lights, with the transistors and the capacitors, and going back and forth, back and forth, back and forth. But there's obviously something wrong with my components, and I don't want to cheap out and do it on TinkerCad. Like, I still totally suggest that you guys use TinkerCad for your models, for your modeling of these circuits. It's a great idea. However, it's something that's not going to happen today, and I don't want to wait a week to finish this video. Okay? So we're just going to move into what this video's purpose was. This video's purpose was to show you that everybody says that, you got to use an Arduino for this, or there's a Raspberry Pi and it's very useful. And that's factually wrong, in my opinion. I am of the opinion that if you can do something with electronics, you should. Because it's a very stable system that can only be burnt out by making a really nasty mistake to yourself. Everything that you can do on these electronic circuits can also be done on a Raspberry Pi board. Let me pull one out here so I can have one in hand and demonstrate for you. Okay. So this is a Arduino AT Mega. This is a board that has pins all the way around it. And to show the alternative, there's a Arduino Uno that has, I think it's got 32 pins. This one having about 50 pins. This is an Arduino Nano that has about 20 pins. Okay? So, the amount of different circuits that can be controlled off of one of these things is finite. And what I want to bring to this course is the ability to take an electronic circuit, connect it to an Arduino with one pin that controls many LEDs, and use the Arduino as a kind of, not a brain, but a controller. The next series, we'll take our Arduino, we're going to take the in-between between these two devices, the Uno, and we're going to make everything we just made today on the Uno, and we're going to show that it takes a whole bunch of pins, and we're probably going to fill up the pins doing all of our programs, right? The one more thing to consider is that, I use ESP32s as my form of Arduino, because the ESP32 has this chip on it. You see this big chip right here? Well, that's an AT Mega chip. They make it in different sizes so that you can make it on different boards, and it's basically the same chip. The thing is it only has one processor on it. meaning that while in the programming loop, you can do a number of different things. You have to be very creative with how you do those different things. If you put a delay in your loop, you actually delay the whole program, and you actually have to take that delay and take it out of the loop and either put it in the setup or the global variables so that that delay doesn't, or in a function, it doesn't restrict the pattern that you want this microcontroller to use. You see, this is a controller of devices. And what we are going to do in this series is next show that instead of taking our electronics breadboard and making just these circuits, we're going to combine one of these with these circuits to be able to do various different operations in a single area of your layout. And because our layouts are very big, we're going to have a microprocessor that will have more than one core on its CPU to be able to control more than one microcontroller at a time. And through that microprocessor, you can automate various parts of a layout. And that makes things very nice for connecting very complicated things to our layouts. However, when you get things explained to you the way I explained electronics to you today, you jump in with both feet and you're able to experiment and find yourself into problems or what have you, and find solutions to those problems, which is kind of cool in my opinion. So I hope you enjoyed the video, and I hope you are interested in joining in future videos. If you want to follow along in TinkerCad, you will be able to follow along all the way up to the point where we start using the Raspberry Pi or the ESP32s. I expect the series to go electronics, Arduino, Raspberry Pi, and then we'll add ESP32s to show that you can do over-the-air updates to change the code on it and do a number of different things on that board that you can't do on a regular Arduino board microcontroller. So thank you for watching, and I hope you liked the video. I hope you found it informative, and I hope it helps you in understanding how to build your layout without spending thousands of dollars. My trigger point while watching people on social media or in forums is watching them say how expensive this hobby is. And today I just proved to you that with $10, you can do anything you want with your layout. And, just because Woodland Scenics makes it easy to connect 10 LEDs up for $60, I'd rather do it for 60 cents, okay? And if you have a problem with, not supporting some company that's gouging you, I'm going to not use the word that I'm thinking, getting you up, you know what I'm talking about here. But that's what they all do. In my opinion, the only companies that you should be purchasing items off of are either kit companies, engine companies like Rapido, or what was the third one? DCC. That's the only three. Oh, the fourth one is microengineering track. You know, because you really can't make your own track. Okay? Well, you can, but you still have to buy the supplies off microengineering to get the rail. But, you know, the idea that building a model railroad is an expensive ordeal is a misnomer. It's completely false. And anybody who says that this is an expensive hobby is full of shit. You know, I recognize the fact that an engine's $300-400, but when you consider the fact that, you know, those engineers put a lot of effort into that engine and it brings you a lot of joy, it's worth it. However, when you take a LED strip from a company that marks up the components by 5,000, 5 million% to gouge you out of money and make this hobby extremely expensive, I find that offensive. So I hope you follow along. And if you want to get a kit from me that has the Arduino Uno and a bunch of electronics to be able to make a bunch of different circuits, I'll get the right transistors, I promise. And in the next video, well, maybe I'll make a video by itself just to show the crossbuck, the flashers, happening. AKA, isotropic or jitter circuit. I think it's called a jitter circuit, isotropic something. However, yeah, or ping pong circuit, whatever you want to call it. I don't care. But you know, thanks for watching. Please like and subscribe. Press the thumbs up button. You know, my channel's on its last legs. If this series doesn't work out, I'm probably just gonna quit. I've got other hobbies, and you know, I'd much rather make you know, a training sensor, a training health sensor for my daughter's horses that uses machine learning to show them if their horses are able to get pushed harder or are being pushed too hard. I'd rather be doing that. And, you know, if this isn't something that you want to see, then that's the way it is. Okay? So thanks for watching. Thanks for watching to the end. Sorry for my attitude sometimes. I get depressive, but, you know, I'm very positive. When it comes to comments, if you're a negative Nancy, I'm going to fly off the handle on you and look pretty ignorant. But if you said that in front of my face, I probably wouldn't say a word, but you would feel every word I thought. Have a good day.